Hello students, today we discuss what is the relationship between speed and frequency in an alternator. You know that in an alternator, rotor rotates by means of prime mover, for which the armature conductor cuts the magnetic flux and hence EMF is induced in the armature conductor, which one is given by Faraday's law of electromagnetic induction. Here this diagram represents the two main parts of an alternator. The outermost part is the stator, which holds armature winding known as conductor, and the internal part is called as the rotor, which holds the field winding. Field is excited by an exciter, for which flux is created, which rotates in an air gap with a certain speed and links the conductor, due to which EMF is induced in the conductor. When the conductor is here, you see the another diagram. This diagram represents how alternating EMF is generated in the armature conductor. Here, when the conductor, this outermost part is the armature conductor or armature winding or stationary part. So when the conductor is opposite to the neutral plane or neutral axis, that is at point A, this point A, C, E, the EMF induced in the armature conductor have minimum value, because in these places the flux density is minimum. When the conductor is opposite to the middle of the planes, that means at point B, D and C, this B, D and F it is, the EMF induced in the rotor conductor is maximum, because in these places flux density having maximum value. If you remember the subject circuit and theory, on that you studied how alternating EMF is generated. When you place a conductor in between a pair of pole, north pole and south pole, suppose this conductor, when rotate from north pole to south pole, then EMF generated completes one positive half cycle, and when again it rotates from south to north pole, it complete another half cycle, which is of sinusoidal in nature. A set of one positive half cycle and one negative half cycle gives one complete cycle. The direction of the EMF when conductor is over a north pole is opposite to that when it is over a south pole. Thus, an alternating EMF is induced in the conductor, which goes through one complete cycle in an angular distance equals to twice of the pole pitch. It means to get one complete cycle, first the conductor passes through north to south, then south to north. So one to complete To get a complete cycle, the distance covered by the conductor is twice the pole pitch. Let capital P is the total number of pole consisted by the rotor. Capital N is the rotor speed in revolution per minute. And F, this is the small f, which is the frequency of generated EMF in Hertz. Since one cycle of EMF is produced when pair of poles passes past a conductor, the number of cycles of EMF produced in one revolution of the rotor is equals to the number of pair of poles. Therefore, number of cycles per revolution is P by 2. If total number of pole is P, then number of cycle per revolution is P by 2. Capital N is the revolution per minute, and number of revolution in RPS, that is small n, is revolution in RPM by 60. Hence, frequency is the product of number of cycles per revolution and revolution in RPS. By putting the value of small n, you get the frequency equation as capital P into N divided by 120 Hz. Here, from this equation, it is very clear that frequency depends on number of pole and speed of the alternator. Hence, capital N is known as synchronous speed, whose value is Ns is equal to 120 F by P, at which an alternator must run in order to generate an EMF of the required frequency. Let us take an example. Here the question is, a four-pole alternator rotates at 1500 RPM. Here by mistake it is ROM, but it is RPM. What is the frequency of the generated voltage? Here the question is to find the frequency, and the given data are number of pole, that is 4, alternator speed in RPM, it is 1500 is given. You know the frequency equation for an alternator, F is equal to Pn by 120. After putting the value, you get it is 50 Hz. This chart represents for producing a frequency of 50 Hz, the alternator will have to run at the following speed. If the number of pole present in the rotor is 2, speed in RPM is 3000. If number of pole is 4, speed is 1500 RPM. If number of pole is 6, it is 1000. If pole is 12, speed is 500, and so on. So it is clear from this above chart, if number of pole increases, speed of the rotor of alternator decreases, and vice versa. So in this video lecture class, I think that you understood about what is the synchronous speed, what is the relationship between synchronous speed and frequency. Thank you.